Hello friends, welcome to this session. In this video, we will be discussing how we can balance any chemical equation. We will explain this with the help of an example, and later you can follow this short trick to balance any equation. This is the best trick to learn balancing of equations. Let us now begin and start learning balancing of chemical equations. First, we will understand that what is the meaning of a balanced chemical equation. So children, a balanced chemical equation is the one which has the same number of atoms of elements on both sides of the equation. That is, the total mass of the elements present in the products of a chemical reaction has to be equal to the total mass of the elements present in the reactants. It would not be wrong to say that mass is neither created nor destroyed in any chemical reaction. Let us now try to understand balancing with the help of an example. Take the reaction of iron with water, which produces iron oxide and hydrogen. Let us examine the number of atoms of different elements on both sides of the arrow. Now, we can observe that the number of iron atoms on LHS is 1 and on RHS is 3. The number of hydrogen atoms on LHS are 2 and on RHS are also 2. And finally, oxygen atoms, which is 1 on LHS and 4 on RHS. It is often convenient to start balancing with the compound that contains the maximum number of atoms. Or, we can also balance the metal or non-metal first, then oxygen and hydrogen. It must be remembered that we cannot alter the formulae of the compounds or elements involved in the reactions. First, we try to balance Fe3O4 and the element oxygen in it. To balance the oxygen atom, we can put coefficient 4 as 4H2O. But remember, we cannot write H2O2 or H2O, the whole 4, like these. Fe and H atoms are still not balanced. Fe has 1 atom in LHS and 3 atoms in RHS. And H has 8, 4 by 2 at LHS and 2 atoms at RHS. So to balance the hydrogen atom, the number of H2 molecules on the right side to be 4. Now to balance iron, on the left side we take 3 atoms of iron. Finally, let us examine this balanced equation. There are 3 atoms of iron, Fe, 8 atoms of hydrogen, H, and 4 atoms of oxygen, O, on both the sides. Now the number of atoms of elements on both sides of the equation are equal. So this equation is balanced now. That is, mass has neither been created nor destroyed. Therefore, the number of atoms of each element is equal before and after the reaction. Friends, as we said, it requires rigorous practice to learn to balance equations. Therefore, you should practice it more and more. For this, we are giving you some unbalanced equations. Stop the video and balance them with the method described, and then match your answer. After this exercise, you will be able to easily balance any equation yourself. Friends, remember, to balance any equation, first the metal, non-metal, then oxygen and hydrogen have to be balanced. We hope that with this trick, you will be able to easily balance the most difficult equations. So friends, Today in this video, we studied how to balance the chemical equation. In the next video, we will learn about the types of chemical reactions. Welcome to this video. In the previous video, we learned about the balanced chemical equation. Today, in this video, we will learn about the combination reaction. Let us now begin with today's topic, combination reaction. Does the word combination reveal anything about it? Right. The word combination tells us that we are combining something. So, how do we define combination reactions? Combination reactions are the reactions in which we combine two or more reactants to obtain a single product. Let us take an example of a combination reaction. Take some calcium oxide, which is also called quicklime, in a beaker and add some water to it. Then touch the beaker. Calcium oxide reacts vigorously with water to form slaked lime, that's calcium hydroxide, and releases a large amount of heat energy. So at the same time, you will see that the temperature of the beaker has increased. Note that in this reaction, calcium oxide and water, H2O, combine to form a product, calcium hydroxide, slaked lime. Two reactants are forming a product together in the reaction. Also, heat is being generated in this reaction. Reactions in which heat is produced along with the formation of the product are called exothermic reactions. We will study them further. Friends, do you know what slaked lime is? Slaked lime is calcium hydroxide, CaOH2, and it is used for whitewashing the walls. And after 2-3 days, you would have observed white shining finish on the walls. Do you know what it is? It is because slaked lime reacts with carbon dioxide, CO2 from the atmosphere, and forms calcium carbonate. And this makes the walls shine. The chemical formula of marble is also CaCO3. Isn't it fun? Let us discuss a few more examples of combination reactions. The first example is that of burning coal. In this, coal, which is carbon, reacts with oxygen to form carbon dioxide. Is this also a combination reaction? Why? Because two reactants, that is, carbon and oxygen, are combining to form a single product, which is carbon dioxide. Hence, it is also a combination reaction. Let us discuss one more example of combination reaction. That is formation of water. In this reaction, hydrogen and oxygen combine to form water. Why is this reaction a combination reaction? Because here two substances, that is H2, hydrogen, and O2, oxygen, together form a single product, H2O, water. Hence, this reaction is an example of a combination reaction. Friends, we have observed in our first example that a large amount of heat energy was evolved when we added water to quicklime. You remember what quicklime is? Yes, calcium oxide, CaO, is quicklime. So students, such reactions in which heat energy is evolved are called exothermic reactions. Let us now discuss a few examples of exothermic reactions. The first example is burning of natural gas. Methane, CH4, when burnt in air, reacts with oxygen to form carbon dioxide and water along with a large amount of heat. So, it is an exothermic reaction. Do you know the process of respiration is also an exothermic process? The food we consume like potatoes, rice, bread, etc. contains carbohydrates, and these carbohydrates are reduced to form glucose, which is further broken down to simple substances like carbon dioxide and water, releasing a large amount of energy. The decomposition of vegetable matter into compost is also an example of exothermic reaction. However, it is not necessary that all combination reactions are exothermic. We can take one more example of a combination reaction, which is burning of magnesium ribbon. Magnesium burns in oxygen to produce magnesium oxide. So friends, today in this video, we studied combination reactions. Welcome to this video session. The topic that we are going to cover in this session is decomposition reaction. Friends, as you know, there are a number of types of reactions, and decomposition reaction is the type of reaction that we are about to study. Decomposition reaction. The word decomposition tells us that it means we are decomposing or breaking down something. In simple words, breaking of a large substance into smaller substances is decomposition. So, how do we define decomposition reactions? Decomposition reactions are the reactions in which a single reactant breaks down into two or more products. Let us take an example of decomposition reaction. Take about 2 grams of ferrous sulfate crystals in a dry boiling tube. Note the color. Now, heat this and observe the color of crystals after heating. You will observe that the color of ferrous sulfate changes from light green to white. You will also observe a characteristic smell of sulfur, and on further heating of the white substance, it will turn into brownish black color. So, we can say that ferrous sulfate crystals decompose to form ferric oxide, which is brown in color, sulfur dioxide, and sulfur trioxide. So students, this is an example of decomposition reaction. Why? Because one reactant, that is ferrous sulfate, is breaking down to produce ferric oxide, sulfur dioxide, and sulfur trioxide. In this reaction, you can observe that a single reactant breaks down to give simpler products. This is a decomposition reaction. Ferrous sulfate crystals, FeSO4 7H2O, lose water when heated, and the color of the crystals changes. It then decomposes to ferric oxide, Fe2O3, sulfur dioxide, SO2, and sulfur trioxide, SO3. Ferric oxide is a solid, while SO2 and SO3 are gases. Isn't it fun? Let us now discuss one more example of decomposition reaction, which is decomposition of calcium carbonate to calcium oxide and carbon dioxide. It is an important decomposition reaction used in various industries. Calcium oxide is called lime or quicklime, is used in the manufacture of cement. Also, when a decomposition reaction is carried out by heating, it is called thermal decomposition. Let us take one more example of decomposition reaction. Take about 2 grams lead nitrate powder in a boiling tube. Hold the boiling tube with a pair of tongs and heat it over a flame. You will observe the emission of brown fumes. These fumes are of nitrogen dioxide, NO2. The reaction that takes place is lead nitrate decomposes to form lead oxide, nitrogen dioxide and oxygen. Friends, let us discuss an interesting decomposition reaction, which is electrolysis of water. Yes, children, water can be broken down into H2 and O2 on passing an electric current through it. The chemical equation for this is 2H2O results in 2H2 plus O2. Decomposition of silver chloride is another interesting example of decomposition reaction. To perform this reaction, place a small quantity of silver chloride AgCl in a watch glass under sunlight for some time. The crystals slowly acquire a grey color. This is because the sunlight has caused decomposition of silver chloride into silver and chlorine. The reaction for this is silver chloride on decomposition by sunlight breaks down to form silver and chlorine. Silver bromide also behaves in a similar way. The reaction shows that yellow-colored silver bromide decomposes by the action of sunlight to give out silver and bromine. These reactions are used in black and white photography. Do you know these decomposition reactions always require some energy? This required energy is either in the form of heat, light or electricity for breaking down the reactants. Reactions in which energy is absorbed are known as endothermic reactions. Absorption of energy causes the breaking of the bonds present in the reacting substance, which decomposes to give the products. So friends, today we have studied decomposition reaction. Welcome to this video session. The topic that we are going to cover in this session is displacement and double displacement reactions. Friends, as you know, there are a number of types of reactions. Displacement and double displacement reactions are the types of reactions that we are about to study. Let us now begin with our first topic, which is displacement reaction. So, the word displace tells us that it means we are displacing or substituting something, right? So, how do we define displacement reactions? A displacement reaction is the one wherein the atom or a set of atoms is displaced or substituted by another atom in a molecule. For example, suppose A is more reactive than B. Then A can displace B from BC and form AC, as shown in the reaction. Let us now understand the displacement reactions with the help of an example. Take 3 iron nails and clean them by rubbing with sandpaper. Then take 2 test tubes marked as A and B. In each test tube, take about 10 ml copper sulfate solution. Tie 2 iron nails with a thread and immerse them carefully in the copper sulfate solution in test tube B for about 20 minutes. Keep 1 iron nail aside for comparison. After 20 minutes, take out the iron nails from the copper sulfate solution. Now, we will compare the intensity of the blue color of copper sulfate solutions in test tubes A and B and the color of iron nails dipped in the copper sulfate solution with the one kept aside. Now, we can observe that blue color of the copper sulfate solution has faded and the iron nail had turned into brownish color. The reaction that took place was iron reacted with copper sulfate solution, and as iron is more reactive than copper, it displaced the copper from copper sulfate and formed iron sulfate and copper. This reaction is known as displacement reaction. Other examples of displacement reactions are: first, zinc reacts with copper sulfate and displaces copper to form zinc sulfate and copper. Next example of displacement reaction is the reaction of lead with copper chloride. It displaces copper to form lead chloride and copper. Zinc and lead are more reactive elements than copper and therefore displace copper from its compounds. We will now discuss another type of reaction, which is double displacement reactions. It is similar to displacement reactions, but the name itself suggests that it is double displacement. That is, there is substitution of two atoms by other two atoms. In reality, such reactions in which there is an exchange of ions between the reactants are called double displacement reactions. Let us understand this double displacement reaction with the help of an example. Take about 3 ml of sodium sulfate solution in a test tube. In another test tube, take about 3 ml of barium chloride solution. Mix the two solutions. What do you observe? You will observe that a white substance, which is insoluble in water, is formed. This insoluble substance formed is known as a precipitate. Any reaction that produces a precipitate can also be called a precipitation reaction. So students, how is this reaction a double displacement reaction? Because chlorine ion 2Cl- displaces sulfate ion SO4 2- from sodium sulfate, and barium ion Ba2+ displaces sodium 2Na+ from sodium sulfate. Therefore, it is a double displacement reaction. Friends, isn't this an interesting reaction? But what causes this reaction? The white precipitate of BaSO4 is formed by the reaction of SO4 2- and Ba2+. The other product formed is sodium chloride, which remains in the solution. Such reactions in which there is an exchange of ions between the reactants are called double displacement reactions. Friends, in this video, we studied displacement and double displacement reactions. Welcome to this video session. The topic that we are going to cover in this session is oxidation and reduction reactions. Friends, as you know, there are a number of types of reactions. Oxidation and reduction reactions are the types of reaction that we are about to study. We will also study about reactions wherein oxidation and reduction occurs simultaneously. Let us now begin with our topic, which is oxidation reaction. So, the word oxidation tells us that it means gain of oxygen or loss of hydrogen. So, how do we define oxidation reactions? An oxidation reaction is the addition of oxygen or removal of hydrogen. Let's understand this with the help of an activity. Heat a china dish containing about 1 gram copper powder. What do you observe? The surface of copper powder becomes coated with black copper oxide. Why has this black substance formed? During the reaction, there is an increase of oxygen in copper. Therefore, we can say that oxidation of copper has taken place in this reaction. And so, this reaction is an oxidation reaction. This is because oxygen is added to copper and copper oxide is formed. If hydrogen gas is passed over this heated material, CuO, what do you observe? You will observe the black coating on the surface turns brown. This is because the reverse reaction takes place and copper is obtained. There is a loss of oxygen in the copper oxide. In the other word, copper oxide is reduced. A reaction in which oxygen is reduced by a substance are called reduction reaction. If we look closely at this reaction, we will find that in this reaction, oxygen is getting depleted from copper oxide. Hence, it is reduced and oxygen is increasing in hydrogen. So, it is oxidized. Any reaction in which one reactant is oxidized and another reactant is reduced is called oxidation reduction or redox reaction. Let us now learn about the reduction reactions. Whenever a reaction results in an increase in hydrogen or loss of oxygen in a substance, such reactions are called reduction reaction. Friends, let us now understand oxidation and reduction in more detail through two examples. In this first reaction, hydrogen is increased in sodium. Hence, it is an example of reduction. In the second example, there is a decrease of oxygen in copper oxide and an increase of oxygen in hydrogen. Let us learn about reactions in which both oxidation and reduction are observed. As we saw in example 2, the reduction of oxygen from copper oxide, that is, reduction and increase of oxygen in hydrogen, that is, oxidation is happening. In this way, oxidation and reduction are taking place in the same reaction. So students, what is the meaning of oxidation-reduction reaction or redox reaction? A chemical reaction in which oxidation and reduction take place simultaneously is called redox reaction. Friends, aren't these interesting reactions? See some other examples as well. In the first example, zinc oxide is reducing oxygen. Carbon is oxidized to carbon monoxide. Hence, it is a redox reaction. In the second example, oxygen is reduced from MnO2 and HCl is oxidized to chlorine. Hence, it is also a redox reaction. In the third example, burn the magnesium ribbon in a bright flame. The white substance magnesium oxide is formed when magnesium is combusted. Is magnesium being oxidized or reduced in this reaction? Yes, because oxygen is increasing in magnesium, we can say that magnesium is oxidized.